Now, and let's start and consider this example, following example, and take this matrix A. It's okay. Our aim here, find the row echelon form of the our matrix A, but then such that, and it means find the matrix B and such that, and our matrix should be row equivalent to matrix A. It's okay. And take the A. It's okay. And look at this matrix is in row echelon form or not, reduced row echelon form or not. This one is leading one, yes. This one is not leading one, this one is not leading one, this one is leading one, it's okay. And also, and not satisfy, and there is no zero row, there is no zero row, and it satisfy the first one. And the second one, every leading one should be, every leading entry should be one, but this one and this one not one, not satisfy. So our aim is to get the row echelon form of this matrix. It's okay. So how to get? And first of all, start with this one. Our aim is to, and also we know that every leading entry, leading one, appears at the bottom. Sorry, at to the right and below, leading ones in preceding rows, but this one is leading entry. This one is leading entry, but not satisfy this condition. So now our aim is to get the leading one here. It's okay. And how to get the leading entry here? It's okay. Write the matrix A. This one is matrix A, first one. Our aim is to get the leading entry here. It's okay. So, and they compare the all rows. It's okay. And then look at this one, and this one. This one is leading one. So I think it will be better. This one should be first row. And so, and use this operation. Which one? Interchange first and last row. It's okay. Last row. And then this one should be first row. 0, 1, 0, 2, 3. Stays the same. It's okay. And then first row will be last row. This one is last row. It's okay. So we obtain the second matrix. It's okay. Second matrix. And operation interchange first and the last row. And means and R4 interchange R1. Interchange first and the last row. It's okay. And the next one, and our aim is to get the leading one here, yes. And the next operation, our aim is to get 1, 0, 0, 0. And the first step, catch the leading one. The next step, we get the 0, 0, 0. We get this column. And so means use a different color. It's okay. This one should be 0. This one should be 0. We have 0 here. So we have to apply the 2 more operation to get 0 here, 0 here. It's okay. So which one? How to get 0 here? And use the always, and I think it will be better, use the leading one and then this leading one, and then we get 0, 0 here. So, and how to get 0, sorry, how to get 0 here, and using the leading one. Take this one and multiply by 1, add to the here. 1 times 1 times 1 minus 1 is 0. Yes. So means operation here should be take the first row, take the first row, multiply by 1 and add to the second row. So take the first row, 0, 1, 0, 2, 3. Multiply by 1, add to the second row. 0 times 1 plus 0, 0. 1 times 1 minus 1, 0. 0, 1, 1. 2, 1, 3. 3, 2, 5. It's okay? And then next operation. First operation, this one, 1. Our aim is to get 0 here. How to get 0 here? Take the leading one, this one, multiply by 2, and then add to the this row, third row. And so, yes, apply 0, 0, 0, 1, 2, 4, 0 times 2, 0 times 2 minus 1. So we obtain, yes, sorry, not multiply by 2, minus 2 here, 0. 0 minus 1. Our aim is to get 0 in this position, sorry. So multiply by 2, of course. It's okay. So 0, 0, minus 2, 2, 0. 0 minus 1, minus 1. And 2 minus 2 minus 4. Minus 4 plus 1 minus 3. And 3 times minus 2 minus 6 plus 1 minus 5. It's okay? So you have to use the notation. First one, multiply by 1. The second one, multiply by minus 2. Or use this notation. Which one? Take the R2 should be R1 multiply by 1 times plus R2. This one. R3 minus 2 R1 plus R3. It's okay. And then the next one should be 0 here. Yes, we have 0 here. So means take the same row. Stays the same, the last row. This one. Yes, we obtain this one. It's okay. Any question? And then, yes, we get 1, 0, 0. And the next step to catch the leading one of the second row. So to catch the leading entry, 1 and 1. Yes, we have 1. So the next one, we have 1. And so next one, we get 0, 0 in this position. Look at this one. This one should be 0. This one should be 0. How to get 0, 0 here? By using the leading one, of course, this one. How to get 0 here? And take this row, multiply by 1, add to the second row and the next row. And how to get 0 here? And take this row, multiply by minus 1. It's okay? Yes, apply these operations. So, and the first row, the same, 0, 1, 2, 3. There is no operation here. And the next one, K row, yes, stays the same, 0, 1, 3, 5. And then apply these operation. Which operation? This one. 1 multiply by 1, add to the next one. And 0, 0, 0, 0, 1 minus 1, 0. And 3 minus 3, 5 minus 1, 0, 0. Yes. So we get 0 row here. It's okay. So apply the next one. Next operation. Next operation and the red one, this one. Take the second row, multiply by minus 1, add to the last row. It's okay. 0, 0, 0, 0, 1, minus 1, 3 minus 3, 5 minus 5. It's okay. So 0, 0, 0. So we get 2, 0 row here. So this one is and the next step. Next step to catch the leading one of the here. It's okay. This one. How to get one here? Our aim is to get one here. It is possible to get one here. Yes, yes, please. It is not possible because what is the reason? Because and the other and the zero rows. It's okay. So we are done. And this one is reduced row echelon form. Row echelon form. It's okay. Row echelon form because zero row at bottom, yes. Every leading entry is one, yes. And the leading entry appears at to the right and below, yes. And also this one is in row echelon form. Sorry, is in row echelon form. Reduced row echelon form, one should be unique non-zero entry of its column. Yes, let's check that. This one is unique non-zero entry. Yes. This leading one is the unique. Yes. And so we have only two leading entry, leading one. There is no other more leading one. So yes, satisfy the third one. And the last condition, yes, our matrix is in reduced row echelon form. So, and these matrix A, not in reduced row echelon form or reduced row echelon form, but the result matrix is in reduced row echelon form. So, and the result matrix is called the reduced row echelon form of the R matrix A. Reduced row echelon form of the matrix A. Yes, we get the reduced row echelon form of the R matrix. Is okay. Yes, this one is reduced row echelon form of the matrix A. This matrix is okay. This one is, sorry. Sorry, there's a problem here. Yes, this one is apply this one and then multiply by 1, multiply minus 2, and then multiply by 1, multiply by minus 1, we obtain. And this one is the reduce row echelon form of matrix A. It's okay. This one is the unique. Any question? Any question here? No question. Okay. Now, there is a problem here. Sorry. I'm sorry. And this one is our example. This one, and we take this one. Is not reduced row echelon form. We obtain reduced row echelon. This one is example 1. We have example 2. It's okay. Example 2. And then let's find the row echelon form example 2. Yes, please. This one is different and from the example 2. It's okay. We have at the matrix A, this one, the reduced row echelon form of this matrix. It's okay. So now let's consider these matrix and find the reduced row echelon form of the matrix A. Yes, yes, please. Apply the sum operation and we get the reduced row echelon form of the matrix. This matrix. Yes. What's the first operation here? For example 2.
I think we should take the first 2 rows to the bottom.
Yes. So what is the first row? First row will be, yes, which one? Choose the one of them. Non-zero entry should be, first non-zero entry should be 1 and also. And this one is non-zero. This one is non-zero. But here 0, 0. So means this one not should be in the first row, not in this position, not the second row will be. It's okay, maybe. But here should be non-zero entry in 1, 1 position. It's okay. Should be a non-zero entry here. So how to get the non-zero entry first row, first column, and interchange row, of course. And here, for example, this row contains the non-zero entry. This row contains non-zero entry. I think appropriate and choose the one of them and interchange row. It's okay. And for example, our aim is to get here non-zero entry. So, and this row contains non-zero entry in this position. So, interchange. It's okay. Row 1 and row 3, first row, and the first operation. And then, sorry. Right here, matrix A, our matrix is, yes, 0, 2, 3, minus 4, 1, 0, 0, 2, 3, 4. It's okay. 2, 2, minus 5, 2, 4, 2, 0, minus 9, 7. Our matrix, this one. It's okay. This one. And now, yes, use a different color. Our aim is to get non-zero entry here. How to get non-zero entry? But look at this one, non-zero entry. So interchange first and third row. Is row equivalent to 2, 2 minus 5, 2, 4. And the second one same, 0, 0, 2, 3, 4. And first row will be third row, 0, 2, 3, minus 4, 1. And the last one the same, 0, minus 6, and this one, yes. So the next one, our aim and the next operation And to get, use a different color. Our aim is to get one here, leading one. How to get leading one? Of course, multiply by, yes, take this one, multiply 1 over 2. It's okay. Our aim is to get the one leading one here. And is row equivalent, apply this operation. Please use the arrows or notation. It's okay. And this one. Depends on you. But you have to use the one notation. It's okay. To see the your operation. Yes, 1 multiply by 1 over 2. It's okay. Take the first row, multiply 1 over 2, minus 5 over 2, 1 2. It's okay. So the others the same. And the next one, our aim is to get 1 0 0 0. So our aim is to get 0 here. So look at this one. Our aim is to get 0 here. How to get? And multiply by, take the leading one, multiply by minus 2, add to the last row. And then we obtain, yes, we obtain 0 0 2 3 4, 0 2 3 minus 4 1. Yes, apply, multiply by minus 2 2 plus 2 0 and minus 1 minus 2 minus 1. It's okay. This one. What's the next operation? Yes, yes, please.
Yeah, the one value on the second row, second entry.
Sorry.
To make one on the second row, second column.
Yes, this one should be
one. So
leading
we
one.
add one first row with second row and write into second row.
And this one, take the operation. Your operation, take the first row, multiply by 1 and add to the second row. It's okay?
But then the second row and the first column would be 1. Then we should use the third row. So we should multiply the third row by 1 over 2, then add with the second row and write in the second row.
And this one is okay. This one is an operation multiply by 1 add to this one. It's not true. It's okay?
Yes, it's not useful because then we would lose the second row. Lose the
this one
0.
Is 1. It's okay? Yes. So not appropriate. And how to get the 0 here? I think interchange row, which and this one, interchange and the second one and the third one. It's okay? Third row. And then, for example, 1 1 minus 5 over 2 1 2, interchange second one and third one, 0 2 3 minus 4 1, 0 0, yes, 2 3 4, the last one the same, 0 minus 2 minus 1 7 3. It's okay, but and we obtain this position, in this position, non-zero entry, but this one should be 1, and so means, and apply this operation, multiply 1 over 2 to get 1 here. It's okay? And the next one, our aim is to get here, our aim is to get, and this one is first column, the second column will be 1 0 0. And so we obtain the next one. This one is 0. Yes, there is no operation, but this one should be 0. How to get 0 here? Take this one, second row, and multiply by 1, add to this one first, and then apply this operation. It will be evaporate. It's okay? Okay. And yes, we have two operations here. Is row equivalent to first one the same. First row 1 1 minus 5 over 2 1 2. Second row and will be multiply but first and sorry, take the third one the same 0 0 2 3 4 and apply this one. Take the second row, multiply by 1, add to the and the last row, and so 0 2 minus 2 0 3 minus 1 2 minus 4 plus 7 3 and 1 3 4, and then apply this one, multiply 1 over 2, it's okay, and 0 1 3 over 2 minus 2 1 over 2, it's okay. Any question? So look at the second column. We obtain 1 0 0 here, this one, and then the next one 1 0 0 0, and the next one, and here, sorry, 1 0 0, and the next step to get 1 here, and then the next step to get 0 here. Any question? Sorry. Of course, and apply the sum operation. It's okay. For example, and here, first one, apply, for example, use a different color. And this one is to get and the 0 here, and then we get this one. Or apply this operation, we get this one, and take the minus 2, minus 1, 7, 3, and then apply this operation. It's okay. Depends on you. But it is not important use which and the operation and the other and the order. It's okay. Apply the some finite operation, but always we obtain the same result. It's okay. Same result. For example, and here and the different and the operation. Take this one. It's okay. Take this one. So and take and the first one 0 2 3 minus 4 1, the same 0 0. This one is 2 2 minus 5 2 4, and apply to this one, and 0 and minus 1 0 minus 2, and then interchange the, and we obtain and this matrix. It's okay, and multiply, of course, 1 over 2. It's okay. It is not important, and for example, and use some finite operation, but our aim is to get, and here to get this shape. It's okay. This one, and then our aim, the next step, to get 0 0 0 here. It's okay. First of all, if we get 1 0 0 0, and then this one is 2, and the next step, first step, and this one, and the next step, for example, depends on you, to get 0 here, apply the and the appropriate and the scalar k. For example, this one is 4 3, and so on. And our aim is to get 0 here, multiply by minus 2, and then and the operation apply to this one 1 0 this one 0 2 3 and this one 0 0. It's okay, but I think a lot of more operation. It's okay, it is not appropriate, but and they use the and these operation and these and the method to get one first one and then to get 0 0 here and then to catch one leading one to get 0 0 0 and then apply to this one and it means and not a lot of and the operation to get the reduced row echelon form. It's okay, but depends on you, of course. And so and this and the reduced row echelon form unique. It's okay. And consider and some more example. So and it is easy to choose and the best way to get reduced row echelon form. Of course, it's okay. Yes, and the next one, our aim is to get one here, and then to get 0 here. If we get and the 0, 1 and then 0, but and the here, this one the same row. It's okay, same entry. So I think it will be appropriate. And look at the third one and the last row and 0 0 0 2 3 3 4 4 and means this matrix has 0 row, at least 1 0 row. It's okay, because what's the reason? Take the this row, multiply by -1, so we get the 0 row at bottom, and then the next one of course multiply 1 over 2, and so we obtain this matrix -5 over 2 1 2 0 1, the same 3 over 2 -2 1 over the apply the operation, multiply 1 over 2 0 0 1 3 over 2 2, and but first one apply this one, multiply by -1 0 row. It's okay. So and the next one, yes, next operation. What's the next operation? Yes. What's the next operation? This one is row echelon form or not? Has 0 row? Yes. At bottom? Yes. Set aside the first one. And all 0 rows at bottom? Yes. And the leading entry should be 1? Yes. Leading entry 1. Leading 1. Leading 1. Yes. Set aside the next one. And the next one to the right and below? Yes. So this one is in row echelon form. It's okay. This one is row echelon form. But reduced row echelon form or not? This leading one is the unique non-zero entry of its column. Yes, it's okay. Look at this one. This one is leading one. This one is 1, but this one is not leading one. This one is only 1. And so look at the second column. Leading one should be non-zero, unique, non-zero entry, not unique. This one should be 0. And look at this one, not satisfied, because this one is non-zero, because not 0. So our aim is to get 1 0 0 and 1, we know and this one, but our aim is to get here, use different colors, 0, and this one should be 0 0. So what's the operation? What's the operation? But here, be careful. I think appropriate here which operation is okay. Be careful. We will use different color. It's okay. Start with the last leading one. Always our aim is to get this one is 0, this one is 0. And then the next step to get 0 here. It's okay, be careful. And yes, our aim, look at the last leading one, this one. Our aim is to get this one is 0, this one is 0. How to get 0? Using the leading one, of course. An operation, take this row, multiply by -3/2, add to the second row. And then our aim is to get here 0. Take the leading one, multiply by 5/2, add to the first row. It's okay. Our aim is to get this one. This one. It's okay. Any question? No. Okay. Apply this operation. Yes. Let's apply. And row equivalent to, yes. And the last row the same. And the third row stays the same too. And yes, apply the first one. This one. Take the this row, multiply -3/2, and then add to the second row. And 0, 0, 0, 0, 0, 1, 1. -3/2, 3/2, 0. This one, yes. What's the next operation? Yes, what's the next operation? Next entry? Yes, please. This one. And 0 -3/2 plus 3/2. 3/2 minus 3/2 minus 2. And then this one. 2 times -3/2, we obtain -3 plus 1/2. It's okay. -5/2. And our aim is to get 0 here. Multiply by this operation. 5/2. 1, 0, 1, 1. 0, 1, 1. 1 multiply 5/2 plus -5/2, 0. 3/2. And this one is 3/2 times 5/2 plus 1. It's okay? This one. Sorry, not this operation. Sorry. Apply this one and first, not the second one. Our aim, not use all of them. Yes, sorry. Yeah, okay, sorry. And our aim is to get, and here 0. How to get? Multiply by 5/2. 1, 0, 3/2, 3/2 times 5/2 plus 1. So, and we obtain this one is, yes, this entry is the result. This one. It's okay. So, and this one 2 times 5/2, 5 plus 2, and we obtain 7. This one. It's okay. So, we obtain column, this one, 0, 0, 1. The next one, previous leading one, our aim is to get 0 here. So, how to get 0 here? It's okay. So, using the leading one, take this row, multiply by -1, add to the first row. It's okay. So is row equivalent to yes, the same. One zero zero nine, this one. It's okay. Any question? We obtain reduced row echelon form. It's okay. Any question? No question. Let's stop here.